The first line of a soil test report will always be pH. That's because the management of soil acidity is essential, with pH having a direct effect on nutrient availability, grass health, and microbe activity. In a nutshell, having your pH within the desirable range will help you to avoid your grass looking like this and more like this. Soil pH is a measure of the hydrogen ion activity in the soil solution. The greater the activity of the hydrogen ions, the more acidic the soil. In contrast, an alkaline soil is dominated by hydroxyl ions. pH is measured on a scale of 0 to 14. The acid range is between 0 and 6.5. And the alkaline range is from 7.5 to 14. At pH 7, the soil is neutral. The pH scale is logarithmic, so a decrease in pH from 7 to 6 is 10 times more acidic. pH is best measured by an accredited laboratory, like ourselves at Lancrop. Here's one of our robotic pH analyzers at work. Soil pH is important for nutrient availability, with the regarded optimum range for pH on continuous grassland between 5.5 and 6.5. This is because many grass species will tolerate more acidic conditions than most arable crops, but grass and clover swards are less tolerant of soil acidity than all grass swards. Even though many grass species can tolerate more acidic conditions, some would advise treating a grass crop like an arable crop, as the optimum soil nutrient availability is between 6.5 and 7.5, regardless of the crop type. If you remember those pots that I showed you earlier, the one here on the right, not looking so well, that one has reduced P availability. The one here on the left, looking a lot better, has all its nutrients in maximum availability. So you can see the growth is much more healthy. So why is this grass crop here doing better than that crop over there? Well, that's because the maximum range of P availability falls in that narrow window between pH 6.5 and 7.5. If the pH drops and becomes more acidic, the solubility of iron is increased. So that iron is therefore more able to interact and form a covalent bond with phosphorus. So that's when you see the locking up effect. If you remember at the start of the video, I explained that it was paramount to address the soil pH balance. If the pH is not at the ideal range, any applied phosphorus can be locked up, reducing its efficiency. In an ideal setting of pH 6.5 to 7.5, an efficiency of 100% would be achieved, so no P wasted through lockup. However, even a small movement to pH 6, remember pH 6 is 10 times more acidic than neutral, 48% of applied phosphorus is locked up, giving an efficiency of 52%. pH 5, the pH is now 100 times more acidic than neutral. So even more iron is solubilised, locking up more phosphorus, and in other words, wasting 66%. That gives a 34% efficiency. It's important to test your grassland soil for pH at least every 5 years, as it could well be that your grass is performing more like this and less like this. Thank you for watching. If you would like to know more about how to take a soil sample and send it to Lancrop, keep an eye on our Grass and Muck Lancrop thread.